50 meters below the surface of the English Channel, there is a tunnel, carved through chalk and clay beneath one of the most unpredictable stretches of water on the planet. It runs for 38 miles, connects two countries that spent centuries trying to keep each other out, and it was built by hand, not by robots, not by some advanced future technology, by man, underground, in the dark, with water pressing in from every direction. When the project was first proposed, the engineers who reviewed the geology said it was possible. The bankers who reviewed the budget said it was not. They were both right. The Channel Tunnel would cost more than double its original estimate. It would push its construction companies to the edge of bankruptcy. It would kill 11 men before it was finished, and it would do something that no structure in European history had ever done before. It would physically connect Britain to mainland Europe for the first time in over 10,000 years. Not since the last ice age had these two landmasses been joined, and the story of how it happened, the decisions, the disasters, the engineering gambles, and the moments it nearly didn't survive, is one of the most remarkable construction stories ever attempted. This is how they built the tunnel that wasn't supposed to be possible. The idea wasn't new. Engineers had been proposing a tunnel beneath the English Channel since 1802. Napoleon himself had considered it. Over the next 180 years, at least 7 serious proposals were drawn up, debated, and abandoned. Not because the engineering was impossible, because the politics always collapsed first. Britain kept pulling out. The concern was never technical, it was strategic. An island nation that had repelled invasions for nearly 1,000 years wasn't eager to build a permanent land connection to continental Europe. But by the early 1980s, the calculus changed. The European economy was integrating. Cross-channel freight was growing faster than ferries could handle. And both governments finally agreed on one thing. Something had to be built. In 1985, the British and French governments issued a formal invitation to private engineering consortiums. No public funding, no government guarantees. Whoever built this tunnel would do it entirely with private capital, and they would own it. That single condition would later become the project's greatest vulnerability. The winning bid came from a consortium called Transmanche Link, a joint venture of 10 construction companies, 5 British, 5 French. Their proposed design was straightforward. 2 rail tunnels, 1 service tunnel running between them, boring machines on both sides, digging toward each other from beneath the coastlines of Folkestone and Coquelles. They estimated the cost at £4.8 billion. They estimated completion by 1993. Both numbers were wrong, but nobody knew that yet. What they did know was that the geology beneath the channel had one section that the original surveys had quietly underreported, and that section sat almost exactly in the middle. Tunneling beneath the English Channel required understanding exactly what was down there. The primary geological layer was chalk marl, a soft, dense, relatively waterproof rock that engineers had identified as ideal for tunneling. It held its shape under pressure, it didn't fracture easily, and it created a natural barrier against water infiltration. On paper, it was perfect, but beneath the chalk marl, running in unpredictable bands through the seabed, were layers of fractured chalk, permeable, unstable, and saturated with pressurized seawater. The original surveys had detected these zones, but their full extent hadn't been mapped with precision. When the tunnel boring machines, each one nearly 300 feet long and weighing over 1,000 tons, began cutting through the seabed in 1988, the crews assumed they understood what was ahead of them. They were wrong. The French side hit fractured chalk within the first few months of digging. Water began pushing through the tunnel face at pressures the ventilation and drainage systems weren't fully prepared for. Engineers on site made rapid adjustments. They increased the ground injections into the tunnel walls. They slowed the boring pace. They added secondary drainage channels. It held, but it slowed everything down. And time, on a project financed entirely by private debt, was the one thing they could not afford to lose. Every week of delay added millions in interest payments to a loan structure that was already stretched thin. Back in London, the project's chief financial officer, a man named John Knowlton, was looking at updated cost projections and seeing numbers that didn't match anything in the original proposal. He requested an emergency meeting with the board. What he presented in that room would later be described by one director as the moment they realized they had already passed the point of no return. The numbers Knowlton presented were stark. The project had already consumed nearly double its initial capital allocation, and they were not yet halfway through. The tunneling crews were working in 3 shifts, 24 hours a day, 7 days a week. Over 13,000 workers were employed across both sides of the channel at the peak of construction. The scale was extraordinary, but scale costs money. and the private banking consortium funding the project was growing increasingly uncomfortable with what they were seeing. In 1990, the banks demanded an independent audit. The auditors came back with a figure that stunned the boardroom. The final cost would not be £4.8 billion. It would be closer to $10 billion, more than double the original estimate. The consortium had two choices: walk away and lose everything already spent, or keep going and hope the tunnel's future revenues would eventually justify the debt. They kept going, but the pressure underground was now matching the pressure above it. In December 1990, the British and French boring machines met somewhere beneath the middle of the channel. A tunnel worker named Graham Fagg was the first man to pass through the breakthrough point, stepping from the British side into the French excavation. It was a historic moment. But what the cameras didn't capture was what the engineers found in the weeks that followed. The alignment between the two sides was almost perfect, off by less than 2 feet over nearly 20 miles of digging. That was the good news. The bad news was what they discovered in the tunnel lining on the French side: a stress fracture pattern running through 400 meters of completed tunnel wall that no one had predicted. And the tunnel wasn't open yet. The stress fractures weren't catastrophic, not yet. But in a tunnel sitting 50 meters below the seabed, with millions of tons of water pressing down from every direction, even a minor structural anomaly demanded immediate attention. A structural assessment team was sent in on foot. They walked the affected section with pressure gauges and core sampling equipment, mapping every crack, every deviation in the concrete lining, every point where the tunnel wall had shifted even fractionally from its design tolerance. What they found took 3 weeks to fully document. The fractures were the result of differential settlement. The tunnel lining on the French side had cured at a slightly different rate than the surrounding chalk, creating microscopic stress points that had gradually widened under sustained geological pressure. It was fixable, but fixing it meant injecting high-pressure epoxy resin into hundreds of individual fracture points across a 400-meter stretch of tunnel that was simultaneously being prepared for electrical installation, rail fitting, and safety system testing. The teams worked around each other in shifts, in a tunnel with limited ventilation, limited light, and almost no margin for error. 3 workers were hospitalized during this phase, 2 from heat exhaustion, 1 from a pressure-related injury during a resin injection procedure. None of them were replaced immediately. The schedule didn't allow for it. By early 1994, the repairs were complete. The tunnel was declared structurally sound. And on the 6th of May, 1994, Queen Elizabeth and French President Mitterrand formally inaugurated the Channel Tunnel in a ceremony at Coquelles. But what happened in the first 18 months of operation was something that nobody in that ceremony was prepared to discuss publicly, because the tunnel was already in trouble again. And this time, it wasn't the structure. The trouble wasn't engineering. It was money. Eurotunnel, the company created to own and operate the tunnel, had opened its doors, carrying nearly £9 billion of debt. The interest payments alone were running at over £2 million per day, every single day. And the passenger numbers in those first months of operation were significantly below projections. The ferry companies had slashed their prices the moment the tunnel opened. Airlines followed. Eurotunnel was caught between 2 industries that had every reason to drive it out of business. By 1995, just 1 year after opening, Eurotunnel announced it could no longer service its debt. The company that had built the greatest civil engineering project of the 20th century was effectively bankrupt. The banks convened emergency negotiations. Debt restructuring talks ran for months. And then on the 18th of November, 1996, something happened inside the tunnel that reframed everything. A fire broke out on a freight shuttle train approximately 18 kilometers from the French entrance. It burned for nearly 9 hours. Temperatures inside the tunnel reached over 1,000 degrees Celsius in the affected section. 34 people were evacuated through the service tunnel. All of them survived. The tunnel's fire safety design, specifically the central service tunnel running between the 2 rail bores, performed exactly as engineered. That service tunnel, which had added billions to the construction cost and been questioned repeatedly as an unnecessary expense, saved every single life. The tunnel was repaired. The debt was restructured. Eurotunnel survived. And today, more than 400 trains pass through every single day. Over 10 million passengers annually. The tunnel that was never supposed to be financially viable became the busiest international rail crossing on the planet. Not because it was perfect, but because the men who built it refused to stop, even when everything said they should. There are more stories like this one. If you want to see them, you know where to find them.